In this video, let us explore the next creational design pattern, that is the factory method design pattern, which is also known as the virtual constructor. So what it is, how to implement it, let's dive in and check it out. Before I implement this design pattern, let us set up the scenario. We all know that there are different types of computers today, like the PC, laptop, mobile phones, tablet PC, supercomputers, mainframe, and many other computers are also there. So in our example, we will only consider the PC and the laptop. Well, what do we need to do for this? We just have to create objects for this. Keeping this in mind, let's write the code. First, I will now create a simple class by name PC. What does my PC has? Let's not worry. Why? Because our main motive is to create an object of PC. Well, to create object, class is required, and that is what I have written here. So let's not worry the other things inside the PC. Similarly, I will now create a simple class by name laptop. Since both the classes are now ready, let us now create object of these classes. I will first create a class by name main, which has the main method like this. Inside my main method, I will first create an object of PC. I'll store the reference inside one reference variable whose name again is PC, and I will also create one more object of laptop whose reference I will store it inside one variable whose name again is laptop. For clarification, I would like to print the contents using system.out.println, and when I now execute, you can now see an object of PC and an object of laptop is now created. According to the principles of object orientation, our objects must be loosely coupled. If you want to implement loose coupling, then inheritance must be there. Well, how to implement inheritance in our case? We all know that PC is a computer, laptop is a computer. Let's implement this in our program. First, I'll now create a simple class by name computer. Then I will tell that my class PC is a computer, which means class PC extends computer. Similarly, laptop is a computer. Technically writing it, I will tell class laptop extends computer like this. I'll come back to my main method and change the type of both the references to computer. Well, if you do this, we have implemented loose coupling. So what is loose coupling? Loose coupling means any object whose reference is stored inside a reference variable of its parent type is only called as loose coupling. Still, if it is confusing you, you can remember like this. On the LHS, the reference variable is of parent type. On the RHS, the object is of its child type. This is what is called as loose coupling. Now that we have implemented loose coupling, when I now execute my program, the output still remains same. Whatever we have done till now, if we have to pictorially represent it, it would now look like this. Me as a programmer, I wanted a PC object, so I created it directly. I wanted a laptop object, so I created it directly. Well, though this worked out, it will become tedious if at all our example include different types of computers. If our example included to create objects of mainframe, supercomputer, server, tablet PC or mobiles, it would become difficult for me to manage and create all the objects because I have to remember all the class names, which is not possible in real-time applications. Well, what is the solution for this? The factory method is a solution for this. How to implement? That's what I'll have to tell you next. The solution for this is don't create the objects directly, rather introduce an interface that will take care of the creation of these objects. Please note, when I say interface, I'm not referring to the Java interface here. I'm only referring to the normal interface, which means the mode of communication or the mode of interaction like the user interface. So this interface here is taking care of the creation of all the objects. Basically, it is acting like a factory that is manufacturing different objects. This factory is manufacturing different type of computers, so hence I will give the name as computer factory. If you want a PC, don't create it directly, rather approach this computer factory and request him for a PC. This computer factory will create and give you a PC. If you want to create an object of laptop, don't create it directly, rather approach this computer factory and request him to give you a laptop. This computer factory will create an object of laptop and he will be giving it to you. So whatever I have now told you, let us convert it into code. First, I will now create a simple class by name computer factory. Inside this computer factory, I'll be now writing a method whose name happens to be getComputer. This getComputer method will now return a PC or a laptop. I cannot mention both of them, so in general I will now tell that this method will return a computer. And the computer that it is returned depends upon the type that it is mentioned to it. So basically I will now tell inside the method, if the type is a PC, then return an object of a PC, like this. If the type is laptop, return an object of laptop, like this. If you do this much, that means you have implemented the factory method pattern. Well, how do we use this if you ask me? Back in the main method, I should not be creating the objects directly, so hence I'll get rid of this line. And I now have to request my computer factory, so I'll tell computer factory dot get computer. First I want a PC, so simply I will tell it as PC. Next, I want to create an object of laptop. I need not create it directly, I just have to request it, so I will tell computer factory dot get computer, and I just have to mention the type, which is laptop. If you tell like this, I'll be getting a laptop. Whether it has really working or not, let us execute and check it. So when I now run it, you can see the output still remains the same. So what does factory pattern means? Factory pattern means that don't create the objects directly, rather create a factory object that will take care of creation of all the other objects, and he will give it to you. So what is the advantage of this? You as a client, you need not worry about the class names, you need not worry how the object is created, you just have to request the factory and the factory will be giving it to you. I hope it is completely clear. If you have any queries, do post it in the comment section below. And don't forget to subscribe and turn on the notification. Why? Because upcoming is the abstract factory design pattern, which you don't want to miss. Thank you.